I'm going to let's just go through the DOM-based ones. These are really simple. But even though they're simple to solve, I really want you to understand the underlying vulnerability, because they almost give you the solution every single time if you care to look. But I want you to understand what's going on underneath and why the solution works. So this is the first one, document write sync. So I'm going to go through here. Okay, so this is the this site. I am going to start with just searching for my username, which is what the code lab has you do, and it gives you back the search results. I'm going to take a look at the view source. So again, I like doing the view source first because you can get the page before client-side JavaScript executes. This is the page. You can see here that this has already been produced, so this isn't client-side generated. But what you do see is that there is a script that gets included. And in this script, when you execute this script, one of the things, so this is the function, it sets this variable query to be the search parameters that you have given it on the search. So again, in this case, it's your Odin ID. And then if it exists, then you call the function track query or track search on the query. And this function does one thing. It writes out into the document an image source tag that is basically a tracker image. And the tracker image includes whatever it was that you queried. And then it closes off the tag afterwards on this. So it's just writing the image tag. And you can see this being done. If I actually then go and see what the results of executing all of that stuff is, you can see in this container, you can see the script right here, as we saw before. And then you can see that it generates this DOM element that's got that search term in there. Now, if you look, the adversary is sitting here controlling the search term. This query term is actually controlled by our search itself. So the next thing I want to try is what happens. So this is what gets generated. But what happens if I try to inject a double quote into this image source tag? So you see that this URI has been denoted with double quotes. Well, first of all, you want to make sure that the single quote can't break this document.write. And as it turns out, I think on this level, anytime you inject a single quote, it gets / escaped. So there's no way of injecting it. But the double quote might actually break this string and then allow you to inject arbitrary things into the image tag. So that's what we're going to try next. So I'm going to go back and then see if what happens if instead of my Odin ID, I give it this. So I'm going to search for that. You can see here's your script. And if you look at how this thing got parsed, it looks like syntax has been broken, right? Like that thing, it's treating my username as an actual tag, if you see the highlighting in this. I hope that's clear. So this means that I actually have broken into this image source tag. And then this allows me to basically inject an attribute that will alert a cookie. So that would be the next thing that I would do on this particular thing. And then I would want to close syntax on this thing after I break it. And so the vulnerability that you might do would be this vulnerability. I'm going to break syntax. I am going to create an onload handler. So when the page loads, I'm going to basically pop up a cookie. And then I'm going to close out the double quotes, because on the other side of this is the double quote angled bracket to close the tag. I got to make sure that I don't break that thing so that it actually renders. And so if I search for this, it will do the alert and then solve the level. Okay, so I hope that makes sense. That's the first DOM level. Okay, the second DOM level, I am going to walk through as well. The second DOM level basically has a form where parts of the form are automatically generated by JavaScript. And this can provide you some useful features when you're doing this. And as it turns out, it's got a default selection feature. And so when you implement an HTML form, you can say to set a default value using this option selected component. And so what this particular JavaScript wants to do is go through all the different store lists. And then if you are on a particular store ID page, it wants to automatically select that as the store that you're going to check the stock on. So that's the functionality of this level that I wanted to talk about first. So if I click details, you'll see on the URL, it specifies the product ID to be 1. And then on this page, we'll do a page source on this thing. What you can see is that this is the stock check form, and you don't see the 3 stores, the options for the 3 stores immediately. So you don't see these elements on the base page. As it turns out, these are things that are automatically generated by the actual client-side JavaScript. And so this is why the script is located right here after the form has been declared. So they're just going to dynamically populate the options in that form for you. And moreover, it's got a list of stores, London, Paris, and Milan. And if you are on a page, so for example, I am on this page where, say I want to be on Paris. If I click check stock on this page, oh, it doesn't show up on the URI. But if I actually specify a store ID of Paris, you can see I'll go here, and then the default option ID is Paris instead of London. And that's done through client-side JavaScript, where you see if you have supplied a store ID parameter, then in the select and the option, I'm going to make sure your store ID parameter, if it exists, your store ID parameter would automatically show up first and be selected. So that's the logic here. The problem with this is that when you are generating the client-side JavaScript here, these stores are, this particular store is controlled by a URL parameter that the adversary controls. And the adversary doesn't have to pay attention to the names that are the locations of your store. Like, there is no code here that checks to see if what the adversary gave you actually matches any of these stores. If it did, there'd be no vulnerability, but it doesn't. And so I can basically create I can basically put HTML directly into my store ID and then get code execution. So that's what I'm going to do next. I am going to specify with my, well, maybe not here. I'm going to specify as my store ID the canonical alert1. I think alert1 will solve this level. And then this will end up solving it. And you can go down here, and then you can inspect this thing. This is a store ID select. And then you can see the option selected. And this has got your script injected straight into the DOM because you have done it this way. All right. That is DOM-based 2. Let me go to the next one, DOM-based 3. Okay, so on this one, the way they get the search results is done on client side. So on the previous example, we have the server side figure out what the search result is and stick it into the UI. In this particular case, we have it being done on the client side. I'll blow this up since I'm going to walk through it here. And so in this one, I take the query from the search parameter. And then I go into here and then I basically set the inner HTML to whatever the search parameter gave me. And then this is a blank span that's initially given to me. I'll just fill that right in. So that's the injection point. And so, oh, excuse me. And so why don't I first try and do the canonical script and see if that, whoops, no, well, that's not going to solve the level. I can try and see if this will solve the level. And if you look, even though I injected this script, nothing happened. And let me go see the page to see if I actually injected this properly. And you'll see at the top, you'll see the blog header, the H1, the search results, and this thing has been filtered out. And so, oh no, it hasn't. This has actually been included. So the search message itself has come through, and this actually, the DOM is actually parsing this as a script. But the problem here is that the way this element got inserted into the DOM was through an inner HTML setting. Now, when you do this, what the thing is going to do, it's going to re-render that element, but it's not actually going to execute JavaScript again. The JavaScript engine has come and gone, the execution of it. So just inserting this script doesn't lead to execution. So that's this forces you to do something else. And that something else is to insert another HTML tag that must be rendered. So an image tag, for example. This forces the page rendering to happen. And then within that element, that image, you can then register an event attribute to do the pop-up. So that's what we're going to do. And the one that we're going to do, let me copy and paste that here. Is this. So this is how it works. I'm going to say, I'm going to include an image because I have an injection point. And the image source is some bogus number, which is 1. And this is going to generate an error. And then I'm going to register an event attribute that says on any error, pop up the alert or pop up the cookie. And then that's what I'm going to search for. And then you see the pop-up show up. And then you can see that this has solved the level. And you can actually see here when you inspect this element, you can see it's been inserted and then it's been rendered. And then you can also see the error where it's not found. The image hasn't been found, which is what that error is. Okay, there's the next one I'm gonna go through. Start that thing up. On this one, this is the JavaScript, the client-side JavaScript. There is a backlink that is implemented on this page that allows you to specify where it is you came from so that you can return back to it. And so this is kind of like an unvalidated redirect where you can specify any kind of return path and it will come at and allow you to set a backlink that will send you back there. And so this is the link that is implemented. So initially it's blank. So an A with an ID, a backlink, and we're going to set the href on this link via client-side JavaScript. And the client-side JavaScript that runs is here. And so this is done using jQuery. And so this is the way of doing it in jQuery is to get the thing that's named. So the $ parentheses is a jQuery shortcut for grabbing a particular element in the DOM. And the element that you want is the element labeled backlink, which is shown up here. And then you're going to set the attribute, the href attribute, which is right now blank. You're going to set it to a URL parameter given to you by basically the adversary. The adversary can set this. And so this is what I'm going to show you first. If I go to this submit feedback link, actually, if I copy the link and I paste it onto this, I paste it into the URL browser, you can see the return path is going to be set to /. So that's what I'll click on this. The return path is being set to slash. And then if I view the page source, you can see here that there is this backlink that's got the text back. And then the script is going to get the return path and then just fill it in. And so you'll see when it renders in the DOM that the return path of slash will be here in an href. So that's what I'm going to do next. I'm going to inspect this. And so you can see that this is the href that gets filled in by the script that executes below, which is what this is. All right. Hopefully that's pretty clear. I can basically do this and say, I want your return path to point to me. And if you go and click this back, you can see that that's not found because that route doesn't exist. But I want to pop up JavaScript. That's my whole goal in life, is to pop up an alert. So I will then do JavaScript alert 1, and then you can get your, when you click on this. So then by doing this, by setting the return path, you now have injected that into this link so that when you click on it, you get the pop-up, and then that should solve the level. But it didn't. Why did it not? Return path is, do I need to alert an actual thing? Oh, all right. I don't know what happened there. Gremlins in PortSwigger's site, I guess. Okay, the last DOM-based one, actually, no, there's one more further down, but the next one is a simple DOM-based XSS reflection attack. This one is much trickier, actually. So this is a really good one if you're stuck to watch. So let me start this thing. This one is not trying to break syntax per se. It's trying to leverage an unsafe eval. Well, it's trying to break syntax on a JSON object in the response. So this is a really tricky level. So I am going to first search on Instacam and show you what the results are. Maybe I'll do this with the. Oh, you know what? I'm gonna show the site first. So I'm gonna go to Instacam, and then you can see the search results show up, and then this UI is given back. I'm gonna now view the page source. And if you look at the page source, you see that this search for search results is the thing that executes here. None of the other things are set. So a lot of the UI for this page, it's almost like it's completely blank. And then this search function is going to go and render everything. It's going to generate all of the elements. And you'll see this on web pages a lot. You'll download a page and you'll be like, this is like completely blank. But then there's this one script that's basically going to do all of the work. And that one script, in this case, is this search results script. And it's going to do a lot. And we're going to have to go through what it does. And it's going to create that whole page experience. But I don't want to view it in this UI because it's not highlighted. So what I'm going to do is I'm going to bring up the document, the developer tools. I'm going to search for this thing again, and I'm going to let it execute. Okay, and this thing has re-rendered. And then I'm going to view this in the sources panel. All right, this is as wide as I am. going to get this a little bit wider. Okay, so you can see when I do this search, then I create a new request, and when it has gotten ready, when it returns, I'm basically going to take the response object and create this string with the variable. So this is raw JavaScript. I'm going to say create this JavaScript statement out of the response text and eval that. So this is also an example of code execution, right? You don't want to do raw code execution because you have to hope that the response from the search doesn't have anything that the adversary controls. And this is where eval is dangerous. You might think that this is safe because this response comes from the server. It comes from the original site, but it's actually being returned from a query that the adversary controls. And so let's go and look at this Ajax request. So we'll go to the network. And this is the Ajax request that we saw in the JavaScript there. And you can see the search term is Instacam. But note that this is the search term the adversary controls, right? And these are the results that are given to us by the server end. This is the stuff we can't control. But the one thing we can control is sitting there right in the beginning, right? We control that. And so maybe because there's basically an eval being done, if I can inject a double quote somewhere here, whoops, sorry. I keep messing up by double clicking. If I can inject a double quote here and end this JSON object somehow, then I could put raw JavaScript that follows this. And because this thing is doing an eval, I can end the JavaScript object, put a semicolon in there, and then evaluate alert 1. And so I can do multiple JavaScript statements by breaking syntax on the response. So that's what we're going to try and do. The first thing I'm going to do is see if I can just do the dumb thing, which is like, OK, double quotes are what I'm going to get to. So I'm going to search for all double quotes. And this thing, gives me all of that. And then if I go to the network and I click on the search term, you can see that the double quote is backslashed. It's backslash escaped. So okay, well, one of the tricks you've probably seen earlier is that is the backslash itself escaped. So we'll try that next. So backslash quote is what I'm going to search for next. And then I'm going to click on the result. And you see, yes, well, here's the problem. The backslash is not escape. So this is the first backslash. This is the backslash that is escaping the double quote. So you can see the backslash is not escaped. But in the response, when you're parsing JSON, the parser is thinking that this backslash is escaping out the second backslash. And then it's allowing the double quote. So this is the difference. We have one thing that fails to backslash escape the backslash, and the other thing that is faithfully applying the backslash on the backslash character. And then that allows us to then slip in the double quote. And you can see upon executing this, JavaScript, you can see in the console, you get an unexpected string. And this is a result, if you go into the sources panel, this is the result of having this be broken. Sorry. Having the response text, the JSON of the response text, having this be broken and then not being able to parse this anymore. This string no longer parses. Okay. So what we want to do is we know that we can end, if we insert a backslash double quote, we can basically escape out of this string, and we can terminate the search term, the JSON search term immediately. So that's what I'm going to do. I'm going to do a backslash quote, and that gets me to the end of this string. I'm going to use a curly brace to get me out of the JSON object, which is what the next character is. And then what I'm going to do is this is being evaluated in that JavaScript string. I can actually end the JavaScript string, the JavaScript statement with a semicolon. And then I can do my alert one. I can say alert one on the next thing with a semicolon. And that's my second JavaScript statement. So that eval is going to do both the search term JSON, the abbreviated search term JSON. It's going to do the alert one. But now I have all this garbage JSON at the end of this response.txt that I don't want JavaScript to evaluate. And so that's what the double slash is for. And so if I send this in, this is what solves the level. And you get the solve. Okay. Questions there at all? All right. I want to get to some of these stored ones in case you get stuck on those. This is the easiest one where nothing is encoded. So let me start that level up. And so this, if you post a comment with raw HTML, when the user goes and renders your comment, you get code execution immediately. And so what I want you to do is submit a post using this script, because we're going to programmatically post a bunch of stuff on these stored. All of the stored levels allow us to post a comment or post something onto a website. So this is the raw code that you'll be using to do that post. And so in this case, all you're doing is basically inserting HTML to alert the document.cookie. And that's what I'm going to show you on this level. So this is the blog. This is the comments, and then you can leave a comment that does basically, you could do that script thing, but I'm going to show you programmatically, because that was the whole point, was to actually do this programmatically. This is the program that solves it. Let me copy the So again, on any post, I can basically post the XSS, that's the canonical alert. And then I can go and trigger the XSS by just reloading the blog post. So I'm going to do this on blog post number 2. I'm going to run the script. Whoops. Of course, the program has to work if I want to run it. I forgot to instantiate a session here. Sorry. I need whoa. And then I can run it. And then what I can do is go to blog post 2. So that uploaded the thing. Well, I guess it already solved it without visiting. I go to blog post 2, and then it alerts me because this thing has been loaded up with that HTML. Okay, that's the easy one. Actually, is quite involved. In fact, this is the one that people have problems with. And I think is part of it is the code lab was not very clear. I hopefully fixed that. So thank you to those who are on the bleeding edge and trying these things ahead of time. It wasn't very clear, and I'm going to hopefully make it clear in this walkthrough what I want you to do. And I need to pull up the code I'm going to use. Okay, so this is the code. I am going to view a post. This is post ID 1. I'm going to post a comment. I'll use my regular stuff and then post a comment. And then I'll get this result. It says, thank you for your comment. I'll go back to the blog. And there's my comment. So let me see the page source first of all. You can see the page source. Almost all of this is server delivered. So server rendered and then delivered to the client. But there is one piece of JavaScript code here. And this JavaScript code says, on click, define this JavaScript and run it. So this is the tracker. It defines a variable tracker, and it sets it to the result of track, where tracker.track is the URI. So, and it actually doesn't do anything, but like this is just an example of some client-side JavaScript that would run. And if you look, this thing is double quote denoted, and this is the link you sent it, so you could try and break syntax with a double quote. But this thing in here is single quote denoted. And so you could also try to break syntax here, because again, the adversary controls this particular link. If you could break syntax with a single quote, this would be the JavaScript that you would want to break syntax with. So I'm going to copy this code, and then I'm going to go back, and then just in a JavaScript console, I'm going to toy around with this code. So if I run this in the console, you can see that the thing runs and it doesn't return anything. So the return value is undefined. But if if you were able to inject into this this URI, say the single quote wasn't escaped, it will be, but we'll talk about that later. But if it weren't escaped, then what would be an exploit that would break syntax and do something for you? So the first thing to try is, what happens if I just inject a single quote to try and break syntax? What would happen? And this would indicate, if I were able to inject it on the web page, I would get the same error as this would generate. And so you see this is generating an error. It says syntax error missing parentheses. And that's because this thing is now missing a parentheses when you terminated the string. And it just basically, it fails out. So if I am able to inject a single quote, I'm going to need to do something to fix this syntax. Well, one of the things I would like to do is to basically run an alert. And I can run an alert multiple ways. I could do this, where I say, I'm going to end this JavaScript. So in this case, sorry. I am going to, end. So this quote, I'm going to inject this quote, and then I am going to inject a parentheses to end the JavaScript. And now I still have that quote. So this is what I'm injecting right here in the middle. And then this will still allow me to patch up the syntax of this JavaScript statement. And then what I can do is I can do an alert one with a semicolon. And then this will actually, this will give me, so because I have finished off the syntax, this also gives me an unexpected token. But what I want to do is I want to finish off the actual JavaScript itself. And so if I comment this out, what you have seen here is a valid set of 2 JavaScript statements that can be used to end this this syntax. So that's what I'm going to do next. And then this will perform the alert. So I have you do this because this is the exploit that I want you to eventually inject into it once you realize that this thing is injectable. So it's a single quote, parentheses, semicolon, alert one, semicolon, and then you can basically inject the comment character to get rid of the original junk. Okay. There's another way you could do this. You could do this as a string evaluation. You could break syntax with a single quote. And then you can do this with subtracting alert1 from this string, which is basically bogus, but JavaScript doesn't care. And then patch up syntax with a single quote, and then end the statement with a semicolon. And then this would also, and then you'll have the original stuff at the end. This will also pop up the pop-up. So this is just multiple ways of doing the exact same thing. Okay. So the next thing that I have you do on this is to go through and try and inject a single quote into this site. And so you'll see on this site, when you do things like, so this is your URL, you're going to inject for links, you're going to try and inject a script tag, and then you'll see it's HTML encoded. You'll try and inject a single quote, and you'll see that this is \escaped in the JavaScript, and it's HTML encoded in the HTML. And then the double quote is the same thing. It's encoded properly. And we're going to run those first. And you might, and just to see that the thing is protected against attack. Oh, I forgot to actually get the URI of this. Oh wait, I did fill in the URI. Did I? Wait. No, I didn't. Sorry. That's not going to work because that site is not up. All right, stop, please. So I post that, and I should get it back. Well, I can actually go into the UI and see it. So this is the innocuous thing, and it gets me back the right thing. Then I insert the script tag. And then if you go back into this and you reload it, you view the DOM element for this link. And then you can see that, well, actually, let me do the HTML, the view source on this thing. You can see here, it's been HTML encoded. And then in the tracker itself, you see that the script tag has been HTML encoded, which is a good thing. Then I'm going to try the single quote on this thing. And then I can go back. I reload the page, see the single quote. I'll view the source. And then in the source, you can see it's \escaped. And this thing is also \escaped in the JavaScript. So I'm all good with those two. I try and inject a double quote, see what happens. Reload, view the page source. You see it's HTML encoded here. It's HTML encoded there, so that doesn't happen. And you look at this is the and quote. And this is the way you inject characters. The next thing I want to try in this program is what happens if I actually inject the quote character. So and quote is the character. Let me see if that actually works similarly, or if that breaks anything. If I reload this, I view page source, and you see nothing has changed here. Well, you can't see it, but like now you can see it. Both of these things are still HTML encoded. The HTML encoding of a single quote, though, is the and apostrophe, APOS. And so you have to make sure when you're injecting that the thing gets escaped out as well, just like the double quote has been escaped out. So that's what we're going to try next. Okay, so the next post that you want to try is to see if you HTML encode the apostrophe and see how that gets included back into the JavaScript, to see if maybe this will inject a single quote into the JavaScript and break syntax there. So that's what the next post is going to do. And if I go back, and this is the blog post, so let me reload this. And you see this is the post that I have just put up there. If I use view the page source, if I look down and see this post, it's right here, the bottom one. And you can see it remains HTML encoded in the link. And then in the, before it gets processed by the DOM, it also remains HTML encoded inside of the script itself. Now, when you're processing the DOM element, there's going to be an HTML decode that goes on before the script gets executed. And so one of the things that we're going to see is that when we inspect this after it's been rendered, you scroll through here, this is the section, this is the link. And so you see that this has been properly HTML encoded, so this syntax hasn't been broken. But in this case, you look and the apostrophe has been rendered. And if it's rendered and then sent into the JavaScript engine, this thing is going to break syntax. And so if I click on this thing, you'll see that on click, this JavaScript will execute, and this should give you an error. And this error should be very similar to the error that we did at the very beginning. So that's what I'm going to do next. I'm going to click on this thing. It's going to run the tracker. And then as part of that, obviously, as part of that link, I'm going to go to the Portland State website, and it's not going to find that thing. But I'm going to see that there are a couple of errors that have popped up. So I'll go to the console, and you'll see exactly that error that was there before when I broke syntax with a single quote. So this means that by doing an HTML encoded apostrophe, a single quote, I've been able to get that decoded inside the JavaScript context of the tracker and then break syntax. And then it goes and it tries to find that link with the single quote in it. So that's the problem. And the reason why I had you develop, or we developed the exploit first, is because all we really need to do is change that single quote to the HTML version of that. And then we have our exploit. And so you can do either one of the two that we developed. Let me see what this Python script does. This Python script takes the apostrophe and then does the very first one. So it ends the JavaScript statement that does the tracker. So in this case, if I go back, so it ends this, whoops. It ends this statement, this tracker statement, with an apostrophe semicolon, and then it adds another JavaScript statement, and then it comments out the last several characters. So that's what the alert does, followed by the double slash, as we saw before. So I'm gonna post that. And then when I go back and reload this page, you'll see this has got the exploit. And you can see in the exploit, if I inspect this, the tracker syntax has been broken, that tracker.track statement has been terminated, the JavaScript statement, a second one has been added, and then this comments out the rest of it. So if I click on this, I should be able to exploit this level, get the pop-up, and it redirects me there. But if I come back to the original page, it solves the level. Okay. So that is the, let's see, that is the third stored level. Let me go and do the next level. I'm going to do, we'll close that off. The next level I'm going to do is the, let's see here, is the DOM-based XSS-stored vulnerability. So it's very similar to the reflected one that we did earlier. And I'm first going to talk about some of the libraries that are used to try and sanitize an HTML encode. sort of sensitive content. And we talked about this in the XSS lecture. You want to make sure that things that need to be HTML encoded are properly HTML encoded. There are libraries for this, but if you decide to roll your own, one of the calls that you could do is, so the string class in JavaScript has a bunch of methods that are associated with it that allow you to do string replacement. So what we're going to do is we're going to first bring up the console, and the JavaScript console, and we're going to start practicing what some of these strings libraries will do. So if I do this, this is basically a string object in JavaScript. I can create a tag out of my name. And then what I can do is if I don't want that tag, if I want the tag to be HTML encoded so that it doesn't break syntax on any of my scripts, I can do a replace operation. And I can say the less than sign, turn that into the HTML encoded version of this. Whoops, forgot the single quote. And then that will return the HTML version of this. And now obviously I have to replace the other character as well. So I can send that to another replace and then do replace that with the greater than. And you'll see, okay, that's one way to do the HTML encoding. One of the things that you might find is that this thing needs to be replaced everywhere. And so what happens if I try and do this? So here I have one tag that's my tag, and here's another tag that inserts, an alert that we have seen before. And I'm going to encode this string using these two functions. And if you look at this, the first two instances of this are replaced, but then the next two are not. And that's the problem with using an incorrect call or an insufficient call to do the replacement. This doesn't do a global replace. And so in order for you to actually do a global replace, you would need to do something different. And so one of the nice things about the console is that it gives you hints as to other things that you could use. So replace all is a call that you could do. And then you would do this call with the replace all. And then you can see everything got encoded in the second version of this. So that's basically what we're going to show. There is a vulnerability on this page that we're going to look at that's trying to do the right thing, but not quite getting there. And that's what this level is. And I probably should have started this level before I did this little exercise, but I guess better late than never. So what we're going to do is we're going to look at the comments. We're going to submit a comment. And we're going to see how the comment has been parsed and included back into the result page. And you'll see that client-side JavaScript is going to take the comment, it's going to try and do the escaping, the HTML encoding of it, and then render the page based on that encoding. So this is the page. Here I'm going to view post. And then you see the comments going in. Let me submit a comment. So let me post this comment. I'll go back to the blog. I'm going to view the page source. And you can see over here, this, you see that none of the comments are initially loaded. It's going to load comments by given an endpoint to basically retrieve the comments from. It's like an API endpoint, a REST API endpoint. It's going to pull it from this path. Well, it's going to call this function, which is going to take that as a parameter. And that function is actually implemented in this script, this load comments with vulnerable escape HTML. It's a very helpful comment. So that's what I'm going to do next. I'll inspect this, and then I will view this script in Where is this script? Oh, it's in the user comments. I'm going to view this script in the sources panel. And you see the sources panel here. This makes a request, and then it gets the response in JSON. The comments that come back are in JSON. And then it parses these things, and then it sends it to this function display comments to basically render all the different sections that you see. And as part of display comments, it gets the element ID. And then it parses each of the entries in the JSON, creating these different elements. And you'll see later on, there is this for the source attribute, there is this escape HTML going on for the sort of the avatar comment. There's also the escape HTML. Where else is it? In the actual inner HTML for the comment itself. And these are places where you're going to basically take all the HTML tags and convert them over into their HTML encoded versions of it. And you can see in escape HTML, it's got this fatal flaw in that it uses the insecure replacement. It doesn't do the global replacement. So this is where you can cause it to fail. In our particular posts, we didn't give it a tag, but let's give it a tag. So we posted the comment, we're going to come back to it. We're going to inspect this page. And you see, this is actually showing up. The tag shows up because it's not a tag. It's been HTML encoded. So because there's only one version of it, actually, yeah. So there's only one version of it. This does not get parsed as a tag. You see, it's in white because underneath, if you view the raw source of this is basically HTML encoded stuff. Okay, so then because this didn't do a replace all, I can do the same thing. I'll do multiple ones of these. So I have 4 of these things. I'll put my name to it again. Post this comment. I'll go back to the blog. And then I see only one has appeared, even though I put in 4. So something is going on. I'll then inspect this element and open it up. And so you see my author name, and then you see a whole bunch of tags that are now appearing within the DOM. Whereas the first one got encoded properly, the rest of them got sent in directly. So then all you need to do is to exploit this level. And again, we are changing the DOM elements directly. So we can't just inject the script tag and then have it, because it won't execute that script. So we are going to inject an image source tag to get the alert. So that's what we're doing. And then we'll put our name in it and then put our website in it. Go back to the blog. And then we'll get our pop-up, and then the thing will be solved. Okay.